Hi everybody, it's Opa Dave. Thank you for tuning in. This is a second part, actually the third part, but second model that we will be building for our project that we're working on. This is a W5 Variac. We will build all of the features on here and have this model ready for us to throw inside our assembly when that time comes. Thank you for tuning in. Like and subscribe. I appreciate y'all being here. Thank you. Bye. All right, everybody. Hi, it's Opa Dave. Hey, I finally found my Variac, and it is quite dusty. Having been in storage for a very long time. It is a W2 type. It is rated at 120 volts at 6 amps. This is on the smaller side of Variacs. So we are going to model this up. It's not going to be with all the wire in it, but it's going to be the major surfaces that we're going to contend with, going to have to interface with, and mount to. I'll also be doing a schematic symbol for this in Circuit Studio. So as I create the symbols for these things, the model of this in 3D so that I can work with in creating the benchtop case. I'll also create schematic symbols for the box itself, and maybe I will publish it as a use at your own risk type of schematic. I am not going to be responsible for somebody else who may or may not know electricity or electronics. Same thing with the last video that I did with creating the panel meters that we'll be using in this. I'll also be creating the electric symbols for those. Same thing with the I have a multifunction display here that will be going on the unit also. It will measure AC volts from 0 to 300 and up to 100 amps, way more than this will ever use. With the workbench, as I build up my workbench, I also have an isolation transformer. I will be using the isolation transformer on the bench also. This may be to isolate my test equipment from the device under test. It could also be just isolating the device itself. If I'm, using a battery operated tool, it won't matter, but just to be safe, we have that will also include on the bench. So in today's episode, we are going to model this Variac. So let's go ahead, and I also pulled up the schematic for it just so that we can take a look at how it's going to be wired. So here is the closest schematic to it that I can find. So I ended up going to here, which we have. It's not by the same company, but it's the same specifications. It is capable of 5 amps and at 120 volts. We will be wiring from pin 4 for our common and 120 volts to pin 5. This will give us up to bring out to this pin here, if we were to continue with the rotation of the knob that will be on the front of this, we can get 140 volts out. So that's what we're going to wire for. And maybe I might consider putting a switch in, a toggle switch, to switch between 120 volts and 140 volts. Not that I will ever probably use the 140 volts, but who knows? Maybe one day, I don't know. Who knows? So that's actually what we'll do. We'll include a toggle switch on the panel that will allow us to switch our Variac from 120 volt maximum out to 140 volt maximum out. So that ought to be pretty interesting. So we will end up having to select a toggle switch here in the near future, and either we'll download that and buy it from a local source that we have. I'm gracious to live where I'm at. I have Mauser in the DFW area, and so if I order anything, I usually order from Mauser, unless of course they don't have it. If they don't, then my next stop will be DigiKey. And if it's just not anything from there, I will go to, now it's called Allied Electronics, or now known as RS Online, or Radio Spares Online. At least I think that's what the RS stands for. I think it's a UK company that has purchased the local Allied Electronics, which was here in the DFW area also. We also, like a lot of cities, we have a Granger. I don't know if it's on my side of town or not, but hey, we'll worry about that at another date and time. So today, back to the Variac. Let's go ahead and get our browser up and get Oh, we have a new icon here, so let's open it up from here. Yay! See how long it takes this to load. I probably should have been prepared and had this on already. There it goes. And then we'll also go to McMaster Car. Will be our supply for screws, nuts, bolts, washers, knobs, because I will need to order a knob for this. I do not have one. And our wire, I think I probably have wire that I can use. But we'll worry about that when the time comes. So, boy, this does take a little while for it to go. There we go. All right. Also, I nobody commented on, but I found that I had on the panel meter from the last video, boy, this is obnoxious. I've been through this I don't know how many times now. Every time you come up, you gotta retell it to save my preferences. Come on there, SolidWorks or Dassault Systems. Y'all need to get your stuff together. But back to the part. I had forgot some information on the part itself, the metadata. And I will also be including the washers and the nuts on the back of the panel because it comes as part of the kit. So we all know that we'll be using those. We'll be finding also some crimpable ring terminals that we'll be using. We won't be using spade terminals unless I absolutely positively have to. Spade terminals, if a screw was to come loose, it can allow a screw to come, a terminal end to come off, and if by chance somehow it might be live on the opposite end that might feed through. If there's no isolation, we don't want to, you know, cause any issues with that. Ring terminals are safer for AC, just because you actually have to lose the entire screw to lose the ring terminal itself. So, but that's nor here nor there. So let's get busy and start a new part. And we'll get into the advanced tabs on here in time. So back again, we're going to be modeling on this particular face. So we'll start there. We also know that this device is square. So we will center around the origin point. I don't know, whatever you call this thing. And let's throw some dimensions on. And we'll fill those in a moment. Okay, we also are going to switch over to metric system here, and let's do, because we know this is square, so let's do equals and click this guy, hit OK. Now, no matter what we do, if we were to come in here and change this to 5, it is always going to stay 5, because these two now are linked together. This is the editable one. This is the one you need not edit anymore because it is tied to this guy. Well, that's interesting that is dragging around that other dimension there. Must be a built-in feature that we didn't know about. So let's start grabbing measurements off of here. All right, we have $114.65-ish. Let's see here if we can get us, yeah, 114.65. We're also going to grab these mounting holes in the corner. We're going to get our measurement there, and that was we got a 6.75 hole. So we know all of them are the same, and we always know they're going to be in the same place. So let's draw some circles and just dump them for right now on the screen. We'll come back and tweak them in a moment. So 6.75. Now let's see what our centers are. Our center is, oops, wrong way. We've got 95.35. All right, so let's go ahead and link these all together. And these are all equal. And let's get us another box so that we can put these into the corners. And let's convert this to construction geometry. All right, we got that. Now let's put you in the corner. Oh, we didn't grab him. There we go. All right, now let's do some. This we said was 6.75. 9.75 millimeters. I see I didn't change that yet, so we will do that here in just a moment. And this was 95.35 millimeters. And we'll call this 95.35 millimeters. And now we also see that we have some pretty big radiuses here on the corner. So let's see if we can get us a measurement for that. And we're going to say this is about say 9.5. What does that look like? All right. Oh, let's go ahead and change this real quick. There we go. Now let's get back into editing. And say 9.5. Come up and we'll grab you guys. All right. The thickness that we're going to be extruding this out is 6.75. No. We'll call it 7. Plus we also have a ridge on here that we're going to need a measurement on. That ain't going to help us out none. And yeah, this is more like this is in inches. Seeing that this is a old or made in America and probably made in the freaking 70s or something, or 80s, because I've probably had it that long. Actually, I've probably had it since the early 90s. All right. One of the companies that I worked for in Virginia, they had periodic sales of old equipment, and you just went out and bid on a pallet of stuff, and I walked away with a power supply, an Acopian power supply, a big one too, and a couple of Variacs and some other equipment that I've since disposed of over the years. So what are we looking at? We're looking at 6.8 millimeters. All right. So let's go ahead and extrude this. Let's get out of that tool, and we have got 6.8 millimeters. I'm already in millimeters, so I really didn't need to type that. I was still thinking I was in the inches. Okay, now let's get on the face here and draw our raised ring. All right. Man, this thing is heavy too. Let's say 3.2. That would be close enough. The mounting holes don't seem to look right with the frame here. Let me make sure I got my measurements right. 114.65. We'll go ahead and just stop right here for a moment. And let's go back and edit this. Oh, 127. That ain't right. That's why it don't look right. Yeah, that was 114.65. Wow. Did I just not... Oh, I know what it was. When I was doing the example, I didn't change it back. So, 114.65. There we go. That looks a lot better. Yeah, there we go. Jeez. It's a good thing, you know, about modeling this stuff. And if you build your features right, and obviously this was early in the process, so kind of hard to mess a whole lot of anything up at this stage. But, you know, there always is that possibility. And this ring is 17 millimeters.